Here's a fun problem. If alpha and beta are different complex numbers and mod of beta is 1, then find the value of mod of beta minus alpha by 1 minus alpha bar beta. Alpha bar here is a conjugate of alpha. We have to find this value. Now I've handpicked this problem because solving this will give us a very good, very thorough practice of a lot of properties of mod and conjugate. That's the strategy. We have to use the properties of mod and conjugate, and especially my favorite one, z bar equals to mod z square. Pause the video, try this on your own. Alright, let's do this together. But before we go ahead, a very quick refresher of mod and conjugate. So mod is the magnitude and conjugate is the mirror image of a complex number in the real axis. So if this is real axis, this is imaginary axis, and this is the complex number. This length from origin to this complex number, that's the mod. To get this length, we have to have the real part, the imaginary part, square, then add them and take a square root. So root a square plus b square, that's the mod of this complex number. The image in the real axis, it's going to look like this. So this is your conjugate. And to get to the conjugate, we move a units along the real axis and minus b units along the imaginary axis. B up and minus b down. So if this is a plus ib, if this was our original complex number, then a minus ib is going to be the conjugate. This is how we represent mod, that's mod z, and this is the conjugate, that's z bar. This is a real number because it's equal to root of a square plus b square. Both a and b are real, their squares are real. If you add them, you get something real, and if you take a square root, you get a real number. But this a minus ib has a real part and an imaginary part, so this is a complex number. Alright, let's quickly look at the properties. You can multiply them and then take the mod. You get the same thing as when you take the mods and then multiply. Same works for division, same works for multiplication of conjugates. If you multiply and then take the conjugate, you get the same thing as when you take the conjugate and then multiply. Same thing works here for division as well. But be careful about these two. When you're dividing, you cannot divide things by 0. So the denominator should not be equal to 0. For conjugates, we have addition and subtraction as well. So z1 plus z2 bar is same as z1 bar plus z2 bar, and z1 minus z2 bar is same as z1 bar minus z2 bar. So these are our usual properties, and we've already talked about this special one. Z bar is equal to mod z square. Alright. If you think this was a good refresher and now you want to go ahead and try this, pause the video, take another shot. Okay, let's do this together. So we have this question and we know that we're going to use some properties. The main clue here is this thing, mod of beta is equal to 1. And if you want to use mod of beta equals to 1, we'll have to figure out some way to introduce beta and beta bar. If we multiply beta and its conjugate, we'll get mod of b squared. That's going to give us 1. So in some form in our solution, we're going to multiply beta and its conjugate. And how do we do that? We don't have beta conjugate here. Well, we can make this beta conjugate by squaring this entire thing. Let's actually go ahead and do that. We're squaring what we have to find. We have to find beta minus alpha by 1 minus alpha bar beta mod. And we're squaring this. So let's start using properties. When we're dividing, we can take the mod first or we can divide first. So in this case, this becomes mod of beta minus alpha square divided by mod of this denominator 1 minus alpha bar beta. That's squared. So now we have a numerator and we have a denominator, and both of them have mod squared. So mod squared is z bar. So let's do that. This becomes this beta minus alpha times its conjugate. So numerator is beta minus alpha times the conjugate of beta minus alpha. And the denominator is 1 minus alpha bar beta times the conjugate of 1 minus alpha bar beta. So let's look at numerator first. Beta minus alpha times beta minus alpha conjugate, or beta minus alpha bar. Can we use another property here? Yes, we can. Beta minus alpha bar is same as beta bar minus alpha bar. We can split this. So this becomes beta minus alpha times beta bar minus alpha bar. Now let's multiply. Beta times beta bar, that's mod beta square, minus beta alpha bar minus alpha beta bar, plus alpha alpha bar, that's mod alpha square. Mod beta square is 1, that's given in the question. So this becomes 1 minus the rest of it. So this is our numerator. Let's see what we have for our denominator. We have a lot of bars in the denominator. So let's have a look. This is the denominator. Now again, using the property, we can split this conjugate. This becomes 1 minus alpha bar beta times 1 bar minus alpha bar beta bar. So this bar splits for these two. What is 1 bar? 1 is a real number, 1 is not a complex number. Or we can say that 1 is a complex number with the complex part, the imaginary part, as 0. So what's 1 bar? Well, this is 1 plus 0i. Its conjugate is 1 minus 0i. That stays 1. So we can write this as 1 minus alpha bar beta times 1 minus, now what's alpha bar bar? That's alpha. Conjugate of conjugate is the same number. And here we have beta bar. Now we expand. This is 1 minus alpha beta bar minus alpha bar beta plus alpha alpha bar beta beta bar. Now this becomes mod alpha square times mod beta square, and mod beta square is 1. So the denominator becomes 1 minus alpha beta bar minus alpha bar beta plus mod alpha square. Note that both the numerator and denominator become the same thing, which means what we have to find, that squared, that's equal to this divided by itself, which cancels out. This becomes 1. So what we have to find, that squared is 1. So what we have to find could be 1 or minus 1. Now which one is it? Well, the answer is it's also equal to 1, because this is a mod of a complex number, that is the magnitude, and it can't be negative. So the answer is 1.